All right, so we're talking about some of the midterm study guide questions, and one of the concepts that comes up is this idea of domain and range in your Chapter 2 studies as you're reviewing. I just wanted to remind you of two of our main domain questions or issues that we have. One is when you have a radical. The problem with domain, domain just means what can you plug in for x that gives you a real answer for y. So can you plug in 0 for this? Sure. 0 plus 6 is the square root of 6, and that's not a handy number, or it doesn't come out rational actually, but it's real. You can square root 6 and you can get an estimate on your calculator. So it's real. We can graph it. You can plug in 1, 2, 3. You could just play around with this, plug in all kinds of numbers. We can even plug in negative 6. Negative 6 plus 6 would be square root of 0, which is real. But if you plug in negative 7, you've got problems. If you try to do the square root of negative 7 plus 6, that's the square root of negative 1, which is the imaginary unit I, which we do not graph. So because it's not a real answer, we're graphing only real answers. When I'm asking you the domain, find the real answers for y. So that doesn't work. So we say the domain has to be negative 6 or larger. And in general, anytime you have a radical problem, you say whatever's under that radical, we call that the radicand, has to stay greater than or equal to 0. And then we solve that equation, in this case just moving the 6 across the line. And we find out that the x values have to be greater than or equal to, so we use the bracket, meaning we can equal that. We're allowed to have a 0, square root of 0, so that's permittable, real, so bracket on that to positive infinity. All right, so the second issue, or a troublemaker I might call it, in domain is when you have a fraction. If you have a denominator with a variable, you always have to be aware of what would cause that to be 0. You cannot have a 0 denominator. That is completely undefined in math. It's not that it's imaginary, it's just not even a number. It's not even defined in our math world. So in this one, maybe it's a little more obvious here. If you plug in 3, 3 minus 3 makes a big O 0 in that denominator, making it undefined. We don't get a real output. Now you can plug in any other number that your heart desires. Plug in 2, 7, whatever your favorite numbers are, you will get an answer, a real answer for every other number that you try. It's just 3 that causes the problem. So the way we express that in interval notation is we say negative infinity up to positive 3. We use a parenthesis for this one because we can't touch 3. 3 is not included. So a parenthesis excludes that actual number, then union, then positive 3 onto infinity. So that's how we express our domain. And then we could talk about range further. But in 2.8, they mainly ask you to give domain answers. All right, so let's get back to some of your sample problems. After the last video, I left off on number 73. On 73, we're continuing along with a composition of functions, and we have a picture form. Instead of saying like f of x equals x squared, for example, it drew the picture of that graph. So function f, there's a picture and it's colored, whenever you're looking at it on your computer maybe. And then g of x is some other equation. Then it asks us to add, subtract, multiply, divide, and it gives us an x value to plug in. So again, whatever's in this parenthesis, this is f of x notation. So you go to x equals that number on the graph, so we know x is negative 2 would be right here. Go back 2 places on the x-axis and then look for function f. Function f is this parabola, and see how high up it is. What's its y value? That's what we're looking for, its y value. At x is negative 2, 1, 2, 3, 4, y is 4. We can say at f of negative 2, the answer or y value is 4. Then we do the same thing for g. Function g, the line, at negative 2, it's up 1, 2 places. So at g, function g, the line, at x is negative 2, the y value, or how far it's up or down, is positive 2. Then it says to add those two answers. So 4 plus 2, in this case, 6 is your final answer to that. So you're just adding the y values. We could have said this is at y is 4, This is at y is 2. 4 plus 2 is 6. We're adding the y values. That's what that means. Okay, let's do it again with a subtraction. We're going to subtract the y values at -1. Again, that's x is -1. So go back, x is -1 would be right there. The y value for g is up 1. The y value for the parabola at, let's see, wait a minute. The parabola is at 1. G is up 1, 2, at -1. How far is function f? Function f is just up 1. So at -1, oh, I made a note here so I'd remember. I looked on the graph that was a little clearer to see on my screen. You might have to blow that up too. There's a little magnifying glass. Sometimes I have trouble seeing them. But at -1, it's up 1. The y value was 1. And then for function g, I think it was higher than that. I think maybe I made a bad note. At -1, 1, 2, 3. 3 or 4. I think it's up higher than that. I'm going to say maybe I did not note that correctly. But whatever it is on your screen, you just count. And if you have grids, it's easier to count. You count how far up it went until you hit, I'm going to say 3. I feel like that's probably a more accurate answer. At -1, function g, the line, it looks like it's up about 3 places. I'm going to go with that. Then it says subtract your two answers. So f subtract g. So 1 minus 3, -2 on that. But just be careful on yours. Count your places. For function f, and do them in the right order, function f is the parabola, so get that answer, y answer. Then function g, and then subtract 1 minus 3, which is -2. All right, next we're multiplying at 0. That one I can see a little better, I think. At 0, x is 0. You know, here's the x-axis. Here's x is 0. For the parabola, it's up 0 places. It's right at 0, 0. So f of 0 is y value of 0. G of 0, the g line, the line here, at x is 0. Again, the x is this way. Here's 0. It's 1, 2, 3, 4 places. I think I made a little mistake there. It's 4 places up. It's not really going to matter what it is because you're multiplying 0 times anything is going to give you a 0. So it says to multiply, FG is multiply those two answers. So since the parabola had a y answer of being at 0 as well, 0 times anything else was going to make a 0 final answer. Okay, one more. Now we're dividing at -1, so look for f, it will be first. F is the parabola. So we go to -1. Now I wrote these down earlier. At -1, f is up 1. So at -1, the y value is 1. And then at -1, the g value, I believe, is up 3. This time it says to divide those two answers. So 1 divided by +3, we're dividing here. 1 divided by 3 for an answer of 1/3 for that. All right, moving on. Next thing we're going to go to your number 74. 74 is 75. I think you got 2 of those. Using the difference quotient. So the difference quotient is a series of 3 steps. For any function, defined function, so 74 gives us a linear function, 3 minus x, and 75 gives us a quadratic function, x squared plus 8, or something like that in yours. Then it asks you to do the difference quotient, which this final step C is the full-on difference quotient formula. So we're just following a formula, but they give it to us in step A, B, and C to kind of work step by step. Okay, so step A says go to your function, whatever function you're working with, and where normally you would have an x here, you change your x to x plus h. Just like if this said do f of 1, that means plug 1 in for x. If it says f of 2, you plug the 2 in for x. Whatever f of whatever is here, that's what you plug in for your x value. So you put this into the x, or x's if there's more than one. So for A part, we have 3 minus, instead of x, we write x plus h. And then simplify that. Really, all we need to do is distribute our negative sign. And I can't combine any like terms, so that is the answer for A part. B part, a continuation says do f of x plus h then subtract the original function in terms of x, like original. So we already have this. That's 3 minus x minus h. So that's that part. Then minus the original function. Now there's two parts to it, so we'll need a parenthesis and distribute our subtraction. So when I distribute the negative sign, I have 3 minus x minus h minus 3 plus x. Now this should simplify nicely in B part. Some good things should cancel out. Notice a lot of good things cancel, and you should get a simplified B part. If not, look back on your steps. So what happens in C part is everything in B part comes out to have an H in it. Some, this next one will have more H's. We only had just the one H term. So when we do C part, we take all that we just did and then divide by H. So I know there's this funny little H in the problem still. So what we've got so far, divided by H, the H's cancel out, and our final answer is just -1. Now this is an interesting little formula, and it's actually kind of, this class is sort of pre-calculus anyway. It's college algebra, which is very similar to what some call pre-calculus, because you're learning the base things you'd need to know if you were going to go through the calculus series. This is a biggie in the calculus series. This is actually how we find the slope of the tangent line of any type of equation that they study in calculus. Well, it makes sense our answer is -1 in this, because this is a line. In a linear equation, we know what the slope is. It's a constant slope. The slope is the slant on the line, and it never changes. The slope's in front of the x. So notice, we knew the slope was -1, and that's really what this complicated formula, in a complicated way, spit out what we've known about lines. But not everything is a line and has just the same slope all the time. As we see, like over here, it's a quadratic, which would be a parabola, and it has a slope that changes. Like over here, it has a negative slope, then it comes down to 0 slope, then back to a positive slope. It gets steeper in places. Oh, sorry, you can't see that. So the slope is ever changing in this. So it won't be as easy just to say that. But no, if you're doing a line one, you can tell what your final answer on C part should be, that slope in front of x. Okay, so let's tackle the formula again. So first thing we did on A part, f of x plus h, which means plug x plus h into any x's in your function. So for that x, we write x plus h, says to square it, plus 8. Now, since we're doing a quadratic, we will need to be careful. That squares out. That means x plus h times x plus h, which is the FOIL method, right? So we'll have to FOIL that. We wind up with 2xh's for your outer, and inner when FOILed. And then we have that plus 8 on the end. That's A answer. B answer, we take what we just did and we build on it. We subtract what we just found, x squared plus 2xh plus h squared plus 8. They're all different terms. Then subtract the original function, x squared plus 8. Now what happens here is it reduces a lot. We get x squared, 2xh, all that's still there. And then we distribute our negative sign, minus x squared minus 8. When we do that, the x squareds cancel, the 8's cancel, and then you just have two terms left, and both of those have an h in it. All your terms that are left in B part, just to kind of check your work, should have h's in them. So when we do C part, we take that answer and divide by h. That's the last step. Divide that by h. Each of our terms should have an h, so when you divide each of these by the h, one of the h's drops out, making that just a 2x because the h's cancel. And then when we divide these two parts, h squared over h leaves us 1h. And that is your final answer for the C part. That would be the slope of the line is a function of the x value depending on where you're at on the parabola. It changes as you move across, the x values. All right. So I think I'll stop right there and we'll come back and do the rest of the problems in the next video.